Often in business, we want to use time series data to predict the future value of an important variable. If the time series is stationary, that is, if the time series exhibits a horizontal pattern without a trend, seasonal effects, or cyclical effects, a moving average is an appropriate forecasting tool. A gasoline distributor wants to use its sales of gasoline in recent weeks to predict the number of gallons it will sell in future weeks. This will enable the distributor to better anticipate demand, which will allow it to reduce the likelihood its supply will be insufficient to meet its demand. This in turn will increase customer satisfaction and then potentially result in higher profits for the gasoline distributor. Sales for the past 12 weeks have been collected. Consider the 12 weeks of data in this table. These data show the number of gallons of gasoline in thousands sold by a gasoline distributor in Bennington, Vermont over the past 12 weeks. For these data, Y sub T is the number of gallons of gasoline sold by the distributor in week T. We see, for example, that Y sub 1 is 17, and Y sub 9 is 22. This means that the distributor sold 17,000 gallons of gasoline during the first week and 22,000 gallons of gasoline during the 9th week of this time series. The gasoline distributor would like to use the patterns that can be identified in these recent gasoline sales data to predict its gasoline sales for future weeks. Here we see a time series plot for the sales data. Note how the data fluctuate around the sample mean of 19,250 gallons. Although random variability is present, there does not appear to be a trend, a seasonal pattern, or a cyclical pattern in these data. This time series appears to be stationary, so application of the moving averages method of forecasting is appropriate. We will now use Excel and a 3-week moving average to generate forecast for these gasoline sales data. The data for this problem have been entered into columns A and B. The weeks in which the gasoline sales were made are in column A, and the gallons of gasoline sold in thousands for each week are in column B. We now enter the label Forecast in cell C1. Note that because we are using a 3-week moving average, we cannot generate forecasts until week 4 of our time series. We now go to the ribbon and click on Data, then click on Data Analysis in the Analyze tab. This opens the Data Analysis dialog box. If Moving Average is not highlighted in the Data Analysis dialog box, scroll through the options in the Data Analysis dialog box until you find Moving Average. Then click on Moving Average and click OK. This opens the Moving Average dialog box. Now enter B1 to B13 in the Input Range box. Click on Labels in the first row to indicate the first entry in the column that contains the time series is a variable name. Enter 3 in the interval box. This indicates that we are using a moving average model based on 3 periods. Finally, enter C3 in the output range box and click on OK. Excel will generate the forecast value for each week and output the results to the corresponding cells in column C. Let's consider how well our 3-week moving average model predicts sales for the weeks in our time series. First, we must calculate our forecast errors for weeks 4 through 12. We enter the label Forecast Error in cell D1. In cell D5, we enter the formula equals C5 minus B5. This is the forecast sales for week 4 minus the actual sales for week 4, or the error the 3-week moving average approach made in forecasting week 4 gasoline sales. We then copy the formula in cell D5 into cells D6 through D13. We can use these forecast errors to find the mean absolute error, the mean squared error, and the mean absolute percentage error. To calculate the mean absolute error, we must first find the absolute value of each of the forecast errors, then find the mean of the absolute values of the forecast errors. To do this, we enter the label absolute value of forecast error in cell E1. We then use Excel's absolute value function in cell E5 to find the absolute value of the forecast error for week 4. And copy the formula in cell E5 into cells E6 through E13. Finally, we use Excel's average function in cell E14 to find the mean of the absolute forecast errors. The value 2.67 in cell E14 is the mean absolute error for a 3-week moving average model. To calculate the mean squared error, we must find the square of each of the forecast errors, and then find the mean of the squares of the forecast errors. To do this, we enter the label squared forecast error in cell F1. We then enter the formula equals D5 squared into cell F5. And copy the formula in cell F5 into cells F6 through F13. Finally, we use Excel's average function in cell F14 to find the mean of the squared forecast errors. The value 10.22 in cell F14 is the mean squared error for a 3-week moving average model. To calculate the mean absolute percentage error, we must divide each forecast error by the actual value of the time series for the same period, multiply each of these results by 100, find the absolute value of each of these results, and then find the mean square of these absolute values. To do so, we enter the label percentage error in cell G1. Then enter the formula D5 divided by B5 times 100 into cell G5. And copy the formula in cell G5 into cells G6 through G13. We then enter the label absolute value of percentage error in cell H1. Then use Excel's absolute value function in cell H5 to find the absolute value of the percentage error in cell G5. and copy the formula in cell H5 into cells H6 through H13. Finally, we use Excel's average function in cell H14 to find the mean of the absolute percentage errors. The value 14.36 in cell H14 is the mean absolute percentage error for a 3-week moving average model. We can now use the mean absolute error, the mean squared error, or the mean absolute percentage error to compare our 3-week moving average model to other possible forecasting models for the gasoline sales time series data.